Hello, and thank you for attending this session on navigating .NET containers on AWS. My name is Carlos Santos, and I'm a Microsoft Specialist Solutions Architect at AWS. What we're going to cover today is a walkthrough of the available services at AWS that support running containers, how to go about selecting the right one for your workload, and the tooling that can help you deploy your workloads. Along the way, I'll demo a couple of services to show how easy it is to deploy containers on AWS. There may be 50 ways to leave your lover, but there are 17 ways to run containers on AWS. This is a great quote from Corey Quinn back in May of last year. If you haven't heard of Corey, I highly suggest following him. He does a great job of telling you like it is in a very humorous way, as you can tell by the quote. Now, this may be how you feel right now, but I'd argue the list of 17 includes tooling that lets you deploy to container services, not just run containers. So let's walk through the services and narrow them down. Some are pretty easy to eliminate based on your use case. For example, AWS Code Build, which is used in your CI/CD pipelines, and AWS IoT Greengrass, which as the name implies is used in IoT scenarios. I want to focus on services that you may use to run typical .NET applications. That narrows down the list to 9 options. These services are purpose-built, and the trick is knowing which use cases they can be used for. At a very high level, the difference between them is how much control you're given. It's the Spider-Man rule. With great power comes great responsibility. Services in the Some Infrastructure Management section are services where you, the customer, have responsibility at the OS level and above. Think of things like patching the EC2 instances. Serverless services aim to have you focus on your application as much as possible and offload the infrastructure management to AWS. It's not that there aren't any servers running, just that you don't manage the servers. This is still a big list, so let's work on narrowing it down a bit more. Lightsail is meant for small businesses and students. It really simplifies management. Lightsail automatically configures networking, access, and security. There are pricing bundles that help you achieve a predictable price. All Lightsail plans include static IP addresses, domain name system management, and there are a number of bundles that include containers, storage, CDN, and databases. While great for small businesses and folks just getting started, it is not typical for an enterprise application. If you have existing Beanstalk knowledge, you can leverage Beanstalk to deploy containers. Now, one item of note is that with Beanstalk, the unit of scale is the EC2 instance. What I mean by that is that if there is a scaling event, Beanstalk is going to launch a new EC2 instance and then deploy your container to that VM. So you have to be conscious of the size of the VM you're using because it is a 1-to-1 ratio. The same is true when you need to run multiple containers. While Elastic Beanstalk takes care of Amazon ECS tasks, including cluster creation, task definition, and execution, if it needs to scale, it will launch a new VM and deploy all containers to that instance. Beanstalk support for containers lowers the barrier to entry since you can leverage your existing knowledge. AWS Batch provides fully managed batch processing at any scale. AWS Batch provisions compute resources and optimizes the job distribution based on the volume and resource requirements of the submitted batch jobs. It also manages compute environments, job queues, and dependencies, allowing you to easily run thousands of jobs. AWS Batch dynamically scales compute resources to run your batch jobs and will utilize Spot instances or submit to Fargate Spot on your behalf, further reducing the cost of running your batch jobs. Batch is great for high-performance computing use cases like end-of-day trading, DNA sequencing, or if you need highly scalable batch computing resources for things like rendering or transcoding. AWS Landa is one of the most used serverless services. Landa is as close as you get to only worrying about just your code. You literally write a function with a specific method signature, specify the runtime, and memory you need, and Landa will execute the function for you. Landa automatically responds to execution requests, and you pay for only the compute time you use per millisecond instead of provisioning infrastructure upfront. If the function is not running, you do not incur any cost. It's awesome for spiky or event-driven workloads because of its integration with a ton of AWS services. It's very versatile. You can use it for web apps, responding to events, and processing data streams. This level of abstraction does come with some trade-offs. You need to understand the service limits so that you know how to operate within them. For example, an instance of a Lambda function serves one request at a time. In order to serve more than one concurrent request, another instance of the Lambda function is needed. Whenever one of these instances needs to be started, that is known as a cold start. There are techniques to minimize the cold start time, but you can't 100% avoid them, so be conscious of your response time requirements. After a Lambda function serves its request, the execution environment is suspended, not terminated, and can be resumed to serve another request. Other items of note are the 15-minute request execution limit, the execution environment is Linux, and you must use Lambda's programming model. While Lambda does support using containers, I'm going to set it aside for now because it does require refactoring your code, and that can be a bit of an effort. Okay, so we're down to just 5 services. These container services give you the same programming model you're accustomed to and can serve multiple concurrent requests. With these 5, I'd argue the first decision is, do you want or need to manage the EC2 worker node instances? If so, the next question is, which orchestrator or platform do you want to use? If you can use a serverless solution, you're down to 2 services. And then it's down to, are you after managed worker nodes or managed worker nodes and a managed CI/CD pipeline? With any of these, the question is, how much control do you need? Let's take a closer look at what I mean by that by looking at these services from a stack perspective. You have always had the choice to deploy your own self-managed solution with the orchestrator of your choice. Essentially, start with a scratch VM and you deploy everything. Ultimate control, but also the most responsibility. In this scenario, AWS abstracts out the management of the physical server and the hypervisor. You can pick your orchestrator, but you have to ensure that the orchestrator's control plane is highly available, and also manage the load balancer, and configuring how to scale, and how to deploy updates. That's a lot. In 2015, ECS came along and provided you an option where AWS managed the container orchestrator for you. This gave you the benefit of offloading the management of the orchestrator control plane to AWS. And there's no additional charge for the orchestrator itself, just the worker node EC2 instances that you're running. In 2018, we added a managed version of Kubernetes. That is our Elastic Kubernetes service. Do note though that EKS does incur an additional charge per cluster. Even before adding Kubernetes as a choice, we were working on lowering operational overhead for customers wanting to run containers. In 2017, we released Fargate, what we call our serverless container service. That's because you don't manage the worker nodes. You just specify how much CPU, memory, and the networking configuration, and then you let AWS manage launching the compute needed to run the containers. The pricing model in this case is at the container level. This level of abstraction is nice, but you still have to manage the container scaling and deployments. AppRunner came along in 2021 and gave you managed CI/CD pipelines. Currently, for .NET, the CI/CD pipeline will only be triggered by an update to the container image, meaning that AppRunner will not compile your code and create the image for you. In all these services, as the level of abstraction the service provides increases, the more opinionated the service is. So let's walk through a chart to help you with the decision-making process. The chart is still a bit high level, and there is nuance to each decision point, but it hopefully helps you to quickly narrow down the choices. As the choices are narrowed, make sure to look at each service's quotas as part of your decision-making process. I can't fit all of those neatly into the diagram, so I'm covering what I consider heavy hitters. If you want to manage the infrastructure as you saw earlier, there's really 3 services to pick from. Now, you may be asking yourself why you may want to manage your own infrastructure. Your requirements may be what actually push you in that direction. Things like needing GPUs, or maybe you want to bring your Windows licenses to AWS, or you want to pack as many container instances in a host as you can as a cost-saving mechanism. If you want the service with the easiest and tightest integration with AWS services, you can't beat ECS. There's no need to depend on add-ons to support integration with other AWS services. If you're already experienced with or are open to the higher learning curve associated with Kubernetes and need the advanced features that Kubernetes provides, like needing over 120 container instances on a single worker node, or you just want portability, Kubernetes is awesome. Similarly, if you're already using OpenShift or like the additional features that OpenShift provides on top of Kubernetes, we've got you covered there. Now, if you're able to not have to deal with managing infrastructure, Fargate is definitely an option. You can have both HTTP and non-HTTP services. The endpoints for those services can be either public or private. Think only clients with access to the private subnet where the container is running can hit that endpoint. It supports Windows, which implies support for .NET Framework. And as you saw earlier, you get control on how to scale the containers. Do note that even if your container is not serving traffic, you're still getting charged for it. And by the way, you do get a choice of using either ECS or EKS as the orchestrator. Though if you want to use Windows containers, currently ECS is your only option. If you only have HTTP traffic that you're okay with being publicly accessible or want a managed pipeline, and you're okay with the fact that currently AppRunner only scales based on the number of concurrent requests being served by the container instance, then AppRunner is your answer. By the way, while AppRunner isn't free when it's idle like Landa is, it does provide discounted pricing, and that is the only one of these services that does so. Let's take a look at how easy it can be with AppRunner. If you got a container in about 5 minutes, you can go from zero to the site being deployed. Okay, I'm here at the AWS AppRunner console. I'll click Create an AppRunner service. We're starting with a container image, so I'll select Container Registry as the repository type. I happen to have a private ECR repository with an ASP.NET image I can use for the demo, so I'll paste in that URI. I'll configure AppRunner to watch the ECR repo for changes to that image and automatically deploy and update. And specify the service role with enough permissions to do so, and click Next. I'll set the service name to My Demo Site, and change the port to 80 since I know that's what the container exposes. Let's take a quick look at the auto-scaling. I'll leave the auto-scaling set to the default of 100 concurrent requests per instance and click Next. And then scroll down and click Create and Deploy. That's all there is to it. AppRunner will provision the pipeline for the automated deployments, also provision the compute resources, the load balancer, deploy the container image, and route traffic to it. Now, while AppRunner will provide a default domain, you can also use a custom domain by going to the Custom Domains tab and selecting Link Domain. I won't do that for this demo though. Now, as you can see, the first step is to create the pipeline used for automatic deployments. Then, AppRunner begins the provisioning process and deploys the image, does a health check, and once the health check passes, it begins routing traffic to the application. Now that the service has reached the running state, let's take a quick look at the web application. As you can tell, it is a default ASP.NET template, but deployed to AppRunner, all in the span of about 5 minutes. Now that you've seen how effortless AppRunner is, you're probably thinking that I've made no mention of infrastructure-related resources, for example, the VPC, subnets, and the container server itself. That's where the tooling comes in. We provide you with tools to ease the effort needed to start using these services. These tools typically come in the form of CLIs. You also have some choices here, so let's narrow those down a little bit. If you're on a platform team and you want to enforce standards that dev teams need to adhere to, then Proton is your answer, because it leverages CloudFormation behind the scenes and you can create your own custom templates. You can pretty much target any service. Out of the box, you get templates for Fargate and Lambda. If you're in .NET already, there's a set of .NET CLI extensions or even service-specific CLIs that you can use to deploy pretty much any service. There's even support for Beanstalk. If you want to use CDK to manage your infrastructure as code, then the recently released .NET CLI deployment extension is the way to go. Though right now, only Fargate and App Runner are supported. If you want to use CloudFormation to manage your infrastructure and you have a Docker file or a container already, then Copilot is a super easy way to get started. If you need help creating a Docker file, or say you have a COTS package and you don't have access to the source code, App2Container helps you containerize the application and deploy the infrastructure. For today's session, we're going to focus on Copilot. Let's take a look at what it takes to deploy a typical web app. In this case, there are 5 resources that are related to the application stack. In reality, though, you have to have the infrastructure stood up, just like you would in a data center. All of the same conceptual things are needed. For example, networking and firewalls. And then you have some of the resources that are service specific. So you end up with 44 resources in total. And you're still not done if you need to provision resources for your CI/CD pipeline. Copilot allows you to worry about just your application, and you let Copilot handle the rest of the infrastructure around it. Alright, let's take a look at Copilot in action. Right, so we're going to essentially start from scratch, and we'll use Copilot to provision the roles and the artifacts bucket, and then we'll let Copilot provision the environment for us. That's going to include the VPC, subnets, and everything else related to that. For example, security groups and route tables. Copilot will also provision an empty ECS cluster and the ECR repository. We'll also leverage Copilot to create the CI/CD pipeline. And while we can't initially create the load balancers and the ECS tasks until we have the code, the initial run of the pipeline will deploy these resources. Then, on subsequent deployments, the pipeline is concerned with updating the container image and updating the task definition to use that new image so that it can be deployed to the services. Alright, let's use Copilot to make this diagram come to life. Okay, we're going to be starting from scratch. So the first thing we'll do is set up our source code repository. Here I am at the AWS Code Commit Console, and I'll click Create Repository. I'll name the repository and click Create. With the repo created, it's time to create the Visual Studio project. I'll create a new ASP.NET Core Web App project. And name it .NET 6 Web, just like the repository. And enable Docker support on Linux and click Create. Okay, next I'll download Copilot into the projects folder. And then connect this project to the code commit git repo. I'll go back to PowerShell and navigate to the projects folder, and then run Copilot init. I'll use .NET 6 Web as the name one more time. Copilot deploys an architecture based on templates that it provides. Here you can see some of them, and what we're going to do is select the load balanced web service. As you can see, there are options to deploy to App Runner and backend services. Copilot provides an opinionated architecture that you're able to customize along the way. Okay, I'm not very creative, so I'm just going to name the service Site. And here you can see Copilot has identified our Docker file. So we'll go ahead and select it and continue. I'm not quite ready to create an environment yet, so I'm going to go ahead and hit no. Okay, with that step completed, let's take a look at what Copilot provisioned for us. To do that, we're going to go to the CloudFormation console. Here you can see the stack that was created by Copilot. And as you can see, it was used to set up the IAM roles that will be needed. Let's go back to PowerShell and execute Copilot env init to create our dev environment. I'll name the environment dev. Next, I'm prompted for which credentials to use. I already have my default local profile set up, so I'm just going to select it. Next, I'm asked if I would like to use the default configuration for the new environment. Now, that includes a new VPC with 2 AZs and a public and private subnet in each AZ, along with a new ECS cluster and a new IAM role needed to manage the environment. The default configuration is good enough for my demo, so I'll select yes, but do note that you can either customize the environment or import existing resources. It takes a few minutes to provision all of the resources, but by the power of television, I've gone ahead and sped up the video so you don't have to wait. Now that the environment has provisioned, let's go back to CloudFormation and check out the details. Here you can see the 2 new stacks that were created. If we look at the environment stack, you will see the new ECS cluster that was created, the security group, along with resources like the internet gateway, the subnets, and of course the VPC. Taking a look at the other stack, we can see that the ECR repository was created along with the artifact S3 bucket. Let's go to the project folder and see what local files Copilot has created. Here you can see the manifest YAML file, which contains the details for our load balance web service. Copilot uses its own domain-specific language that simplifies the declaration of resources when compared to CloudFormation. Now that the environment has been created, let's go back to PowerShell and create our CI/CD pipeline. The first step is to run the Copilot pipeline init command. While Copilot supports following multiple branches, we only have one in this project, so we'll leave the default and associate the dev environment to that pipeline. Copilot will set up the CI/CD pipeline to not only build a container image, but also deploy to the dev environment. The pipeline init command creates the artifacts that we need to commit to our source code repository locally. Let's jump over to Visual Studio so that you can see the list of files we need to commit. I'll navigate to the Git Changes window, and here you can see the files that Copilot created. Much like the previous manifest file we saw, Copilot created another manifest file for this particular branch. And as you can see, it provides the information for both the source code repository as well as the deployment stage for the dev environment. I'll go ahead and enter my git commit message. And then select Commit All and Push. With the changes successfully pushed, we're ready for Copilot to provision the CI/CD pipeline. To start the process, we execute the Copilot pipeline deploy command. This command creates one more CloudFormation stack to deploy the code build project, as well as the code pipeline. Now that the command has completed, let's jump over to CloudFormation and look at what was provisioned. As you can see, the new stack has created the code build project and the pipeline, along with the IAM roles and policies needed by both. Let's jump over to code pipeline so that we can see the pipeline in action. Here you can see the build is currently in process. Once we get to the deploy stage, we'll see that since this is the first deployment, the ECS cluster and other resources will be created. I'll speed up the video here so we don't have to wait as long. Okay, we reached the deploy stage. Let's go back to CloudFormation. And here you can see the dev environment stack is being updated. As you can see, it is the load balancer that is being created. If we jump over to the site stack, you can see that the ECS discovery service is being provisioned. The load balancer target group has already been created. And if I refresh, you can see that the ECS service is now being created. As well as the already created task definition. Let's go back to code pipeline and wait for the process to complete. I'll once again speed up the recording so that we don't have to wait as long. Now that it has completed deploying, you can see that the total time was about 10 minutes. Remember that this includes the one-time deployment of the complete resources that we just went through. So subsequent deployments should be faster. Okay, let's take a look at our deployed site. I'll jump over to the dev environment stack to get the load balancer's DNS name. And click on it to navigate to the site. As you can see, it is the ASP.NET project template. Alright, time for a quick recap. You saw that with just 4 Copilot commands, we were able to deploy not only the infrastructure needed to run our application, but also a CI/CD pipeline that automates future deployments. Copilot init created the roles we needed, and EMV init created the baseline networking resources. We then used pipeline init to create the artifacts and used pipeline deploy to create the pipeline itself. Then the CI/CD pipeline took over, created the rest of the ECS and load balancer resources, and deployed our application. Further deployments would only involve the last step of updating the task definition with the latest container image, as well as updating the ECS service to use that new task definition. Hopefully, that demonstrates how Copilot can become a valuable tool in your toolset, as it can quickly get you up and running using best practices when you're either beginning your migration journey or are standing up a new project on AWS. Copilot doesn't stop there though. Copilot also helps you with the operation of your application. It allows you to see your application's health, view your logs, and leverages ECS exec to allow you to connect to an interactive shell on your running containers, as well as letting you configure your application's autoscaling. AWS Copilot is a tool that can help you throughout your application's lifecycle. Let's take a closer look at the .NET CLI extensions I previously mentioned. I'll cover the new AWS.NET deployment tool for the .NET CLI, which is currently in preview, but in the near future should be reaching general availability. As you'll see, the goal is for it to simplify the deployment experience for .NET developers. I'll also mention some of our other .NET CLI extensions that are service-specific, but provide features that go beyond just deployments. Earlier, I mentioned that if you would like to use the AWS Cloud Development Kit, or CDK as it's more commonly known, to manage your projects, the new AWS.NET deployment tool for the .NET CLI is the way to go. While Copilot is an application framework agnostic tool that lets you deploy applications written in multiple frameworks, including .NET, the new AWS.NET deployment tool for the .NET CLI takes advantage that it is .NET aware and can inspect your application to provide smart recommendations. It makes it easy to deploy .NET applications to AWS even if you have never used AWS before. It can inspect your project and create the CDK project for you. If you aren't familiar with the AWS CDK, the CDK allows teams to define their infrastructure as code using programming languages. In our case, it would be C#. The CDK generates the CloudFormation template you can use to deploy your stack. The Generate CDK project includes the code needed to provision the target environment and the required IAM roles and permissions. The new CLI extension inspects the project and recommends the most appropriate deployment option. Currently, it supports ECS with Fargate, AppRunner, and Elastic Beanstalk. It is baked into the AWS Toolkit for Visual Studio, and as you'll see in just a bit, it provides a simplified deployment wizard. You can then modify the CDK project to fit your specific use case. As we saw earlier in the flowchart, the one caveat with the CLI extension is that it does not support .NET Framework applications. In that case, Copilot is a better fit. The latest version of the AWS Toolkit for Visual Studio includes the new Publish to AWS feature, which leverages the new .NET CLI deployment extension. This new feature simplifies deployments right from your IDE. There is now a single deployment wizard that lets you target multiple services. .NET developers no longer need to know ahead of time what their target environment will be. The new tooling inspects the project and makes intelligent recommendations. You're also able to edit the settings, including whether to create a new ECS cluster or use an existing one, and the same goes for VPCs. You can either create a new VPC or use an existing one. Other things that can be changed are items like the auto-scaling settings, things like min-max capacity, the scaling metrics that you should use, and the desired count of ECS stacks that should be running. Alright, so how do you get started? Well, because the new AWS.NET deployment tool is a .NET CLI extension, the installation process is likely one you're already familiar with. You would execute the .NET Tool install command with the G flag to make it globally available, along with the name of the extension, which is aws.deploy.cli. This will add a new AWS deploy command to the .NET CLI, which you can use to start a new deployment. Very similarly to Copilot, the CLI has multiple deployment options. After a deployment option is selected, the new tooling automatically generates a Docker file, if one doesn't already exist, and an AWS CDK deployment project, and then deploys the project to AWS. The creation of the Docker file is one other feature that sets the .NET CLI extension apart from Copilot. If you remember, Copilot lets you start from a Docker file, not create one. The IDE integration and the CLI workflow is great and all, but you may be thinking, what about CI/CD pipelines? You can turn off the interactive features of the tooling by specifying the silent parameter. This enables scripting and automation of deployments. Settings for a deployment are declared in a separate JSON file, and the settings are passed into the deploy command via the apply parameter. This parameter lets you specify the JSON file that should be used, and the same settings I mentioned earlier are all configurable using this file. So as you can see, the new AWS.NET Deployment Tool .NET CLI extension provides tight integration with .NET and the Visual Studio IDE to ease deployment of .NET applications on AWS. That's not where it ends though. Remember the other service CLI extensions I mentioned? While the new AWS deployment tool for the .NET CLI is attempting to unify the deployment mechanisms under one banner, there are 3 other extensions available which have been for some time that are service specific. The Amazon.Lambda.Tools extension provides commands that let you manage Lambda functions. For example, you're able to set the runtime configuration, and you're also able to do other actions like invoke the Lambda function and publish and manage Lambda layers. The Amazon.ECS.Tools extension lets you either push an ECR image or deploy to ECS, configuring your container to run as a service, a one-off task, or even a scheduled task. In this case, the CLI will set up a CloudWatch event schedule rule to run your application. The Amazon.ElasticBeanstalk.Tools extension has commands that let you manage Elastic Beanstalk environments, as well as creating the application package you can use to deploy to Elastic Beanstalk. Alright, those are the 3 additional .NET CLI tools currently available. Let's finish off our tour of tooling by covering apt2container. AWS apt2container, or A2C for short, is a command line tool for modernizing .NET and Java applications into containerized applications. A2C analyzes and builds an inventory of all applications running in virtual machines, on-premises, or in the cloud. You simply select the application you want to containerize, and A2C packages the application artifact and identified dependencies into container images. It also configures the network ports and generates the ECS task and Kubernetes pod definitions. With A2C, you can easily modernize your existing applications and standardize the deployment and operations through containers. A2C is great when you need help creating a Docker file or when you want to package applications you don't build from source. Let's take a closer look at the process at a high level. On the left, you have your applications. Now, they may be running on premises on a traditional server or VM, or they may even be running on a cloud provider. The first step in the process is for apt2container to analyze the server and identify which workload apt2container can containerize for you. With the workload identified, you can analyze the application to identify runtime dependencies. That will allow you to extract the application and create the container image. You can then generate the deployment artifacts and deploy the image to Amazon Elastic Container Registry, and then deploy the image to either ECS, EKS, or App Runner. Optionally, you can create the CI/CD pipeline as well that will deploy the image to your environments. Note though that this pipeline does not include building your application from source code. Let's dive a little bit deeper into the process. Let's take the scenario of a .NET application running on a server. You run apt2container inventory to find the candidate applications. You'll then get a list of applications that can be containerized. You can then analyze the application, say for example, identify the IIS configuration, and say if you're also moving the database, you then update the connection string. You can then extract all of the artifacts, which you'd upload to S3, and then you can use your apt2container workspace to build and push the container image to ECR, and register the ECS task definition. At this point, do note that nothing has been deployed yet. Then, when you deploy, the service will be created and the image deployed. That's all there is to it. These 6 steps allow app-to-container to containerize your applications. If you want to get hands-on with any of these tools, we have various labs that help you gain some experience with them. We have labs covering Copilot for both .NET Framework and .NET, as well as labs for the new AWS.NET deployment tool .NET Cli Extension and app-to-container. And while we didn't cover Proton today, here are a couple of videos to help you get on your way. In this session, we saw the available services at AWS that support running containers, how to go about selecting the right one for your workload, and the tooling that can help you deploy your workloads. I hope you enjoyed this session and found it informative. Thank you for watching.